All right, well, thank you everyone for holding tight. We now have Jesse Lee, president of GoProto. We made it. Thank you so much.
There we go.
There we go, there we go. We hear you, we see you. All you have to do is share your screen, and then we'll be able to see your presentation. I'll stay here until that's loaded.
Okay, so screen 2 is being shared here. Thanks everyone for waiting there through the little technical glitch.
Perfect, wonderful.
So you can see there's a, great, we good?
You're all set, thank you.
Excellent. Well, thank you everyone. I appreciate you joining, and Janet and Andrea, thank you very much for setting up this meeting in these tough times. Just wanted to quickly discuss, we've got now about 20 minutes. I'm going to go through about 15 slides or so to discuss on-demand custom manufacturing and taking a product idea into production, primarily focused around additive and primarily focused around additive polymers. Our company, GoProto, is kind of what's called a service bureau. We're just a rapid manufacturer using 3D printing as well as traditional technologies like machining and injection molding. So here's our opening screen here, just showing some basic parts, some of the machines that we're working on. So just a quick, I've got 3 slides or so that discuss GoProto real quickly, and then we'll go through and talk about some of the qualifications for using additive for product development and also production. And then I'm going to go through some use cases because I figured that the group may be real interested to see what other people have done and what's worked and what hasn't. So quickly, just kind of who are we? Why do we matter? GoProto is a group of industry veterans. We've been involved in additives since the introduction of stereolithography in the early 90s. We've run through pretty much every additive technology that's out there or that has come through the space, may not exist any longer. We've come from being a one-stop shop. We manufacture using both new additive technologies as well as traditional technologies such as machining, sheet metal, rapid injection tooling, cast urethane, compression molding, lots of different technologies to manufacture parts. So we're able to really objectively look at projects that come to us, discussions with customers, long-term consultative relationships, to discuss with customers what they're looking for, what they're trying to do, and really have a full toolbox that allows us to cleanly, objectively look at what their needs are and recommend the right solution, which at this point we're going to discuss how that might end up being additive. So as I mentioned, end-to-end solutions for plastic and metal parts. And an important thing of, again, who we are, why we matter, we're part of the HP Digital Manufacturing Network, or DMN, which some of you may have heard of, which kind of shows a level of qualification that's quite high. And I'll go through what the DMN means here in a little bit. So next slide, just a quick note about our locations. Our primary manufacturing facility is in San Diego in the United States. We have a project administration location in Mexico. We do a lot of our operations, a lot of manufacturing, as I mentioned, the kind of traditional technologies that are done in our facilities in China and Taiwan. And we also have a manufacturing facility in Australia that has manufacturing there. Next slide. So this goes through our full breadth of solutions, and this is important to see. As I mentioned, we do everything from concept models, the early phase industrial design models, looks like, feels like. Want you all to understand that we kind of come from the understanding of the art of product manufacturing, of taking concepts through to production. And this isn't just for, I want to make sure some of the folks here are going to be inventors, makers, doers kind of on their own, on the side, small companies. Others are large companies with large R&D plans, big efforts at product development. And either way, you're going to need to ideate, create concepts, sell your product design to your stakeholders within your organization. So working with a partner such as ours that understands the art of making products is important. And then we utilize the remaining tools here, 3D printing, machining, tooling, molding, sheet metal, all the rest of these, to go through the various stages of product development from that concept model on through manufacturing, production, and sometimes that includes finishing. Of course, there's also a subcontext under all this of inspection and validation. So all these services are right at our fingertips. So now I want to talk a little bit about additive, and this kind of specifically we're going to be branching off. We offer fused deposition modeling, or FFF, stereolithography. This is multi-jet fusion we may be talking about here. We offer additive metal as well. We have some capability with polyjet. So a lot of things, a lot of technologies at play here. But going through your project, why might you want to use additive manufacturing? What in your product development cycle may guide you toward using additive? And some of the things might be things like speed. How quickly do you need to get your ideas into physical part that you can test, show, take photos of, whatever it is that you need to be doing with it? Additive is an extremely exciting technology to allow you to get parts out very fast. It also employs design and feature freedom. We've all kind of heard that complexity for free. There are lots of other considerations. I showed just kind of a thumbnail picture of a part down at the bottom that might allow you to, or that might necessitate using additive. The next bullet down, cosmetic needs, also show here that this part is printed with texture, with geometric texture. There's also some undercuts that the whole feature section in the middle is raised proud. So traditional tooling or machining wouldn't allow you to be able to make this part. So if you were making features like that, had difficult undercuts, lots of complexity, you could look to additive. I wanted to talk just briefly about this idea of mass customization, because in additive that is a big kind of buzzword of this idea of being able to take a basic design, make slight tweaks to it to customize the product for unique customers. And that could be things like footwear, that could be things like that tend to interface, say, with the human body. That might be modifying something just a little bit to, say, incorporate a new part number. There's lots of things that can be done with mass customization, and additive lends itself to that extremely well, since there are no tooling changes generally to be made. Distributed manufacturing might be a qualifier for using additive. And distributed manufacturing means, I pointed earlier to our facilities in Australia and San Diego. We have a customer that I'll show as a case study later that has distribution in Australia and California, and it's very helpful for him to have us be able to print parts in Australia, for example, and distribute there, thereby avoiding shipping costs across the ocean. So that is something that's becoming more and more interesting to companies as logistics become more difficult and more expensive. So that's a big possibility for using additive. There's this, of course, this idea, this holy grail of being able to eliminate or minimize tooling, meaning injection mold tooling, forming tooling, stamping tooling, bending tooling for sheet metal. And that's an extremely exciting positive for additive, because, of course, there, as far as the manufacturing of the part, there is no tooling. So you can make modifications on the fly. It's also very quick to get your first part, since you don't have to make tools. Then the last two here are small quantity or just-in-time ordering plan. Additive is very, very exciting, because you can just make a couple parts and have them done, either just that's it, or maybe you're going to be making a bunch of them but just want to order 20 or 50 a week or a month, something like that. This allows you to do that much easier. There's often no minimum order quantity. Then last is price. I kind of put that at the bottom here because price economics kind of vary depending on the process. If you're just making a few products, you want to get them out into the market quickly, you want to use them yourself, use them within your own organization, the price for additive can be extremely low, and that might be very compelling. Now, as you go up higher in quantity, the parts are more labor intensive, so they tend to be higher cost than what injection molding is. And if you graph out tooling cost and quantity, you may, or price and quantity, you may see that soon they cross over and you end up being less expensive for injection molding or machining. So it varies depending on your process. We can help you go through that analysis. Okay, then, rapid product development using AM. So some other things to consider here are process considerations, like, does your part lend itself to printing? Meaning, does the geometry, is it good for printing? Is it going to come out with good quality? Is it designed such that the process makes good parts? Does the need for precision match the process? That's important to note that If the part is really highly precise, additive or particular technologies with additive may not be the best fit for you. So we'll kind of go through that and look at what your needs are. Maybe something where you combine, say, printing with post-machining to get a surface flat or hit tolerance. Is speed of additive manufacturing sufficient for your needs? So this is something we're facing now. Really interesting tool to be able to use for the manufacture of medical components in the fight of coronavirus, that we are able to get parts out very, very fast, but ramping up to super high quantities is difficult with additives. So we want to make sure that we are matching the technology with your capability. So the speed can get up to some parts really quick. Lots of mass customization or mass produced parts can be more difficult with additives. So it kind of depends on the technology. Multi-jet fusion tends to work very well in that because it can produce a lot of parts quickly. Cosmetic expectations matching reality. Well, again, want to make sure that you're able to meet the spec with what the manufacturing technology is. I'll show you some pictures here in a little bit. I'm going to kind of go through the rest quickly because we're running quick on time. So, who's your manufacturing partner and what can they do? Do they have the right equipment? Are they willing and able to consult with you about your project and kind of walk you through what all the requirements are and if the technology matches? This is important to know if additive is a good fit. And then can we deliver consistent quality? Do they have a plan in place? Are they experienced with manufacturing in a production environment? And if so, will they be able to apply that to additive? That's something we've focused on very hard. There's this whole environment around traditional technologies. Additive is building up to that. What do we have for quality? How do we inspect? How do we verify and validate that the process is consistent? And then, of course, will capacity meet your needs? And then for you individually, if you're talking about you as an individual versus a large company, either way, you're going to have the same question of what's your plan for the future? You're going to keep these products in life for a long time? Is it a slow time? Is it something that if you validate a process now and then don't reorder parts for a couple, you're going to be able to get the same technology and repeatability later? That is very important to consider. Okay, then just briefly, talk about. I mentioned we're going to talk about the DMN, the Digital Manufacturing Network. This is something that HP has worked on, trying to set a standard for the additive space. Those two customers that if they come to a digital manufacturing network, parts that they need, so they don't have to recreate a whole plan around the technologies to be able to get them to qualify. So this brings to customers or companies looking this technology to their portfolio, that this is kind of pre-qualified essentially, so that you don't have to worry about the basics of, does the company have an action plan, a engineering group that can help. This sort of pre-qualifies, so it goes through that talks about this. 6 worldwide that were early foundation partners in the DMN, so we've worked hard on helping standard qualified. Okay, then I wanted to start talking about and looking at some actual parts. And the top left picture is a multi-jet fusion part that has only been tumbled, hasn't been finished. So that's kind of the basic standard. That will only take you so far. If you want to go into using parts for production, you need to know, are they going to match cosmetics? We've worked very hard at establishing other finishing technologies that'll work well for this process, such as dyeing. Back to that center picture, vapor smoothing works extremely well for multi-jet fusion parts, makes them look close to production, also improves their mechanical properties. We've employed hydrographics to be able to do all kinds of different leatherette, metal plating look. Just sample pictures here. Cerakote also is an exciting. It allows parts to be chemical resistant, UV resistant, heat resistant, adds a whole bunch of mechanical properties that the raw parts or even vapor smooth parts do not. Then of course painting and metallization. So if you are looking at going into production, you need to look at what are the cost requirements and working the ability to match your cosmetic requirements. And so I wanted to show here that we've worked hard on that, and it is definitely something for you to consider. Is this standard gray tumble going to work? Do we need to dye it? Do we need to paint it, or add some other secondary process? So that's the other thing that comes into play is size. The printers can only print a certain volume, and if the part exceeds that, you want to know that you're working with somebody that has the technology to be able to create parts in sections and then fabricate them together. It's difficult. There's some understanding of adhesives, some understanding of fixturing to be able to hold parts in place while they are bonded so that you end up with the proper shape dimensions. That's something we've focused. All right, so if I'm looking over I don't see any questions yet. Thank you for putting up the slides in the chat if people can't see my screen here. I wanted to look at one in particular, just as a case study. I've got about 5 here. We'll go through just a couple because of the amount of time left. First, we wanted to talk about this company called Rope's Edge that is what used to be known as Access Anywhere, changed their name. So if you've seen them, that may be where that's coming from. I have a video here that you'll be able to watch on the presentation later. I believe I'm going to skip the video due to time. But what it talks about is this man, Dirk Doornbos, he's a single inventor that is a subject matter expert in access tools for construction and other environments. I think I might be able to forward it a little bit to show the part. So there's Dirk. He's a single inventor. He has this product that he came up with that solves a market need, but it's a very challenging part. It requires somebody. I mean, he's hanging here from the part. Did various technologies and found that multi-jet fusion was really the only one that worked. So we were able to test the parts and then run just more of them in the multi-jet fusion machine. There's the part screwing into place. That's the part. Rope threads through it. So here's an example of who came up with an idea. Here, I'll just go to the slide here. Came up with an idea, printed some parts, tested them very carefully because there's a lot of safety involved here, and they qualified. So then he was able to produce just a low quantity of parts at low cost, hit his price target. As I mentioned before, we were able to print in multiple locations, saving him shipping costs. Lead time was only 5 days to get him some parts that he was actually able to use. Then, as I mentioned here, it's an aggressive mechanical load environment. In the past, parts, even selective laser sintering, some technologies in FDM that were considered tough still weren't non-isotropic or isotropic enough to be able to handle the load. So this process worked. We're also able to print in there by reducing his part count. So this is a really exciting example of how you could take a concept into production quickly, use it, then turn around and be able to sell it at pricing that allows you to hit the margin targets that, and then just in time as we go forward. So there's that. I wanted to show that we did, we worked through this with him carefully. This is a picture of multi-jet fusion builds where we were analyzing how we're going to be able to build the parts, nest them so that we could get maximum efficiency and lowest part price, best quality. So we go through and talk with customers about this and analyze these sorts of things very carefully up front in engineering. So as you move from prototype into production, this sort of close partnership is important. So there are other case studies that are in here. We're running down. We've got 4 minutes here left. As you look through this PowerPoint after the presentation, it's going to be available on the website later. You can kind of look through more. But I did want to show, this is just a quick one here. I want to show this graphic. The whole idea here is being able to take a design cycle and compact it, reducing your cost, increasing your profitability. You're still going through the basic, all these important phases of prototypes, pilot run, testing, but with additive, you're able to do it faster than if you were, say, machining or injection molding or any of the other technologies that for these guys that were low quantity, that worked very well for them. So with that, I'm going to roll into question and answer, being that it's 11:27.
Yes, thank you for that, Jesse. I think we have a few minutes.
All right. Yes.
The first one, is your business mostly for prototyping, and are you seeing a transition to production for your customer base?
I'm sorry, the beginning of that, Andrea, was just a little broken up. Can you repeat the question?
Oh. Is your business mostly for prototyping, and are you seeing a transition to production for your customer base?
Good question. I mean, our name is GoProto, which indicates prototype, but we are production. We've been doing injection molding and sheet metal and machining production for years, so we're very experienced in that. However, we are seeing exactly what the questioner asked of customers that are starting. In fact, Dirk was a good example of that at Rope's Edge, where he started with some. I think we made 5 or 10 or so. He tested them, and then he was able to go into production using additive. So that's a good example of a customer that has taken the what was initially a prototype into production using additive. So that's happening more and more, and that's at both small companies and companies.
Awesome, thank you. Another question from James. You said tumbling or finishing of parts improve material properties. Can you please explain on this?
What I was talking about in particular on that one was, if the screen is still being shown, talking about smoothing back here on this. So vapor in particular, tumbling is just the process of removing power up. That doesn't really change the mechanical properties, but vapor smoothing here does, and that is a process where we have a machine where we take the parts, place them in the machine, it exposes them to a vapor that reorders the surface molecules and kind of locks them together, and it gives the parts a smooth appearance. It locks the molecules together, so the parts end up being stronger. They have better elongation, so that they're more impact resistant. They're able to stretch better. And it actually improves some of the other mechanical properties as well. So yes, it really does change the mechanical properties in a positive way.
Awesome, thank you. And I saw quite a few questions on Cerakote. Is this a ceramic coating? Can you elaborate a little bit?
Absolutely, yes. It's actually Cerakote, and so that first part is Cera, meaning ceramic. And actually, this is a standard. If you look at www.cerakote.com, you can get examples there. It's generally used for industrial applications such as firearms. It's ceramic, so it's got high lubricity, so it's used for high wear parts. It's also impervious to many things. I mentioned UV, chemical resistance, heat resistance, so it's applied to hot parts that get hot, like engine manifolds and exhaust parts and so on. So it's something that takes a post-bake, so you apply it as a paint and then post-bake it. And to this point, most of the other additive technologies in polymer have not been able to take that post-bake heat, but multi-jet fusion can. So it's a really interesting and exciting new application that's now available because of the toughness of this new material and new process. Uh-oh, muted. Andrea, you're on mute.
Thank you, Jeff.
There we go.
We'll end on one last question from an anonymous person. How many machines does GoProto operate?
Good question. In many, depends on the process. With multi-jet fusion, we currently have 6 of those machines, which is part of the answer. We've also got a bunch of processing stations and build units, which allow us to put through a lot of parts in the multi-jet fusion process. So we're able to run a lot. Then in fused deposition modeling, FDM or FFF, we've got 6 machines. And then in SLA, we currently run 2 at our facility in the US. I mentioned Australia. We've also got multiple MJF and FDM machines there in both monochrome and color, and then machines in Asia, primarily for the traditional technologies. So we've got huge capability, allows us to run through a bunch of different possible scenarios and really truly suggest the right solution for the customer, not just the one that we happen to have a printer or 2 in one technology.
Awesome. Well, thank you so much, Jesse, for joining today.
Sure.
Of course.
Thank you all very much for joining. If anyone has any questions on the presentation that you'll be able to join, my contact information is there. I'm, of course, available as well. So thank you all very much for attending.
Thank you.
Sure, thank you.